good morning, guys. Today we have Leetcode questions, and we'll see. Okay, so 328 odd even linked list we have, and the question is saying that we have. Give me 1 minute. Yeah, we have odd even linked list, right? In which the question is saying that we have given a singly linked list and group all the nodes with the odd indices together, followed by the nodes with the even indices, and return the reordered list. Means the first node is considered odd and the second node is even, and so on. Note that the relative node inside both even and odd group should remain as it was in the input. You must solve the problem in O of 1 extra space complexity and O of n time complexity. Make sure. Okay, so space complexity and time complexity is already given. You don't have to think about more than this space and time. So this is the linked list we have, right? And it is saying the 1 2 3 4, right? Means we have 1 is odd, 3 is odd, and 5 is odd. So we will collect all 3 in the first group, and later the sum 2 and 4 will be later. Okay, these are the nodes. We will combine it and then we will return as a output. So I think there is no doubt, but make sure you will take care of the space complexity and the time complexity that is given. Similarly, we have another questions in which it is given already, right? So the odd is it is not starting with odd, it's starting with even. Okay, but make sure the first is odd, right? 2, then 2 is, we will make 2 is odd, then 3 is odd, then 6 is odd, and then 7 is odd, because the question is already saying to you the first node is considered to be odd, second is even, and so on. So these criteria should not be uh, mismatch. Okay, you can say should always mismatch, should always match, sorry. And then we have to return the value. Okay, let's go to the constant, and you'll see that that is not required. Let's go to the a problem in which you can see that linked list is already defined, and the linked list is a class, and we have two val and next node, in which when we create a constructor through without any value, this constructor will call, and if you're passing an integer in the while creating a node, then we have to pass some value. If we do not have, then we have to pass value and next node, and this will store the value, value equal to value and next equal to next one, right? So we have given a list of node in which head is already given, and let's find out. So the coming to the solution sector, we have to check that what is the intuition behind this problem. So intuition is to put the odd nodes in the linked list. All the node we have to put into the linked list, and the even node in the another. Correct? Means we will take two linked list in which we will collect all the nodes in one linked list and another in another list. Okay, so that will called odd odd node linked list and even linked list. The even list is the tail of the even, will be the tail of the odd list, right? So first we'll call odd, right? Odd linked list you can say, and then it should become even list. Okay, like this. Now we will see the algorithm in which the solution is saying it is very intuitive, and but it is not trivial to write the concise and bug-free code. A well-formed linked list need to be two pointer, head and tail. Correct? Head and tail should be there to support the operation at both ends, and the variable head and odd are the another are the head pointer and tail pointer of the linked list, and we call odd list. The variable even head and even are the head pointer and tail pointer of the another linked list, and we call the even list. So the algorithm traverses the original linked list and will put the odd nodes into the odd list and even into the even list. So to traverse the linked list, we need at least one pointer as an iterator for the current node. Okay, so it is saying to traverse the linked list, we need at least one pointer as a iterator for the current node. And but here the pointers odd and even not only serve as a tail pointers but also act as a iterators of the original linked list, right? Original list we can say. The best way to solving any linked list problem is to visualize it either in your mind or in a piece of paper. So let's understand here an illustration of our algorithm. Like if we are coming to this point, right, in the initial step, you can see that we are taking head here, right? We are taking head here, and this is the head, right? And the head will point the first node, right? And first node is what? 1, and that is the reason we are pointing head to the first node. That is called also odd, and it should be there should be one another node that point to the second, right? This was the first node. Now this is a second node, so this will point to the even. Okay, and it's the head of the even is what? 2, but the head of 1 is what? 1. Okay, and even head is what? This one. There is one head and there is a even head, right? So two head is there, one for the odd. For the odd we have what? This head, but the even we have this head, correct? And so on it will move. When we come to the step 2, in which we will see that the head is pointing to 1 now, but now it's points the odd is pointing to what? 3, correct? Odd is pointing to 3, and even is now at what position? The next position we have, like this position is here, but the even contains now, and even head is now at what? 2, and now its points to next point. It is showing that is at 4. So even is at here, and the third step even will it come. Now the it is separating, you can see that, right? Now this is called for the odd 1 3 5, and for the even we have here 2 4, and next it is pointing to null, so even is at null. So and next of the odd is also pointing to null, so we do not have to move to another point, and that's why this is called the final step. And we will have head 1 2 3, and now the tail will be what? Even, right? 2 4, and the next point is what? At null. So you don't need to point it out, but you can leave it here. So this is all we have for the odd and even linked list, and make sure that we will follow this problem here. Okay, so the algorithm you understood, right? So what we will do here, we will first take as a line number 13, we will take a head equal to null. If the head is null, we will return null. Okay, so this will be your base case, so that we will not go into the infinite loop, and will return from the head equal to null, means we are not going to do anything, we will return the null as a linked list. No, now we will take odd equal to head, right? Odd we will initialize as head, and even as head dot next, correct? And even will be what? Even will be even. So 3 pointer at least you should have. Odd, correct? You should be have odd, then even, and then sorry, odd and even. Odd will point to head, even will point to head dot next, and there should be one more, what? Even head, correct? So now we'll check the even not equal to null and even dot next not equal to null. Then we will move one pointer odd dot next equal to odd dot next equal to even dot next. Okay, and odd equal to what? Odd dot next. We will move to one pointer, and even dot next equal to odd dot next, and even equal to even dot next. And another point what we have, odd dot next equal to even dot head, and we will return the final head, right? You remember that you see here this illustration, right? First what we have 1 2 3 4 5, right? 1 2 3 4 5. If you will write 1 2 3 4 5. Okay, so first pointer, you see, first pointer is what? Head. Head is pointing to what? This one. So head is pointing to this one, and there is one what? Even and odd, right? So see, odd is at what? Here. Odd is here, correct? And even is what? Here. Even is here. But there is another one is even head, right? Even head, and it is pointing to here. 1 minute. Correct? That's why, and this is called head. Correct? This is head. So linked list have two node we have to define. The first is at least two. The first is odd and second is even, right? Odd and even is required. Odd and even is required, and you can see that odd is directly points to what? Head. That head is connecting the link. Initial linked list we have head, and that points to odd. So we will initialize the odd with head, and that we are doing here. Correct? That we are doing here. Now we have even, and even is what? Head dot next, right? This, we are not pointing to this one, but we are pointing to what? This one, right? And even head we have, right? Even head is what? The same position, right? We have same position, because we are what we are trying to do, we are trying to create two lists, for the even and for the odd. For the even and for the odd. For the even, if we'll consider for this one, right? So now odd have what? First this one, right? And this is called for the odd, if you consider like this. And you will consider for the even here, right? So head dot next is what? At 2. We are pointing to 2, and as well as there is one even head, right? That is called even head. Even is a head at what? This position, okay, currently, and we will move to the next position. And but the head is pointing to what? Head is pointing to here only. Correct? Very simple. Now we'll come to the while loop, in which we have to check what? Even should not be equal to null. If even is null, means we are not going to the next position. We don't have anything else, anything to the next position. And because even should be at the last position always, right? After even there should be null node only, and then we will check even dot next should not be equal to null, because when we try to go to the next next node of the even, and that should be the node, that should not be the null case, right? In that case we will make the condition even should not be null and even dot next should not be the null. But when we come to this point, right, in which we are saying odd dot next equal to even dot next, means what? For this one the next pointer should be what? After this, right? After this position, so it should go to what? Here, this position, and this should not, right? That's the reason we have to give what? Even dot next. And when we check with the odd, right, we have to check up, we have to update. Now odd should be not be here, this is pointing to here, right? This is pointing to here, so now we have to update it, right? So odd should be cut from here, and it should point directly to what? This position, and that is called what? Even odd dot next, right? So odd equal to what? Odd dot next, because now odd is pointing to what? Next position, correct? So this point is also done, correct? Now even dot next is what? Odd dot next, because this is odd now. Odd is at what? This position. So after this position, this dot next equal to what? This one. So this should be at the what? Even position. Even should be here, and odd should be what? Odd is already at what? This position. So we have to give even dot next equal to odd dot next, correct? And that's why the both will move. So this is also done. Now when we come to even, right, so we have to update the events. Actually this position, this odd equal to next, right, and even equal to even dot next, we are updating our pointer. What we are doing, we are updating our pointer to 2 points, but we are moving with this one, odd dot next equal to even dot next, and even dot next equal to odd dot next, right? moving like this, or.next equal to event.next and event.next equal to or.next. In this way we are moving, but we are updating odd equal to or.next and even equal to event.next. And in the final section, so this is also done, right? So final point what we have or.next, and in which we are what we are doing or.next equal to event.next we are doing, because this is updating, right? This is updating at each point. So or.next equal to what? Event.next. So when this will come 1 2 not 2 3 and 5, right? So the odd next should be what? It should point to what? This position, and that's why we will connect this one. And finally we are connecting here. How we will do connect? This is called connecting to linked list, right? What we are doing, or.next equal to event head. So we have updated finally, and then we will return what? Head. Okay. So time complexity you have seen here that will move to the all linked list, right? All the nodes or link, all the node of the linked list, and that's why it is called O of n, right? Time complexity. And where the n is what? Total nodes, and we have to visit each node, correct? And space complexity will remain 1 because we are not taking extra space. All we need is 4 pointers. What? Odd, even head, right? And head. Only this we are using, so we don't have to take extra space, and that's why the example is very good for us to understand. Please comment with your example if you like, and you can like this program, then please subscribe. Thank you so much.